Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 2463. It's a two-day contest problem. Minimum of total distance travel we have to find, and this is ExpertFunda. If you are new at ExpertFunda, please subscribe this channel and keep supporting ExpertFunda so you can get a better content. Okay, let's try to understand first. The question saying that we have to find the minimum total distance which is traveled by the robots. What the question saying that there are some robots and the factories on x-axis, and you are given an integer robot, right, array, where robot at I is the position of the ith robot. You can also you are also given a 2D array that is called factory. Means two things we have given: the robot we have given and the factories we have given. So robot at each element is nothing but the position of the ith robot, where the factory we have given is the combination of two things. Where first have a position and another is limit. Means the factory position and its limit, that indicates the position of the ith factory, and J is the limit, you can say, of the robot. How many the factory can repair how many robots, that is called the limit. So the position of each robot is unique, and the position of each factory is also unique. Okay, means both positions are unique. Note that the robot can be in the same position as the factory initially. So all the robots are initially broken and they keep moving in one direction. So direction can be a negative or positive direction, you can say, in the along with the x-axis, where a robot we can say is having some conditions. So when a robot reaches a factory that did not reach its limit, the factory repairs the robot and stop moving. Okay, means when a robot reaches a factory that did not reach its limit, okay, and the factory repairs the robot and stop moving. This is a very good point. Okay, so at any moment you can set initial direction of moving some robot. So your target is to minimize the total distance traveled by all the robots. Okay, in that case you have to return the minimum total distance traveled by all the robots, and the test cases is generated in such a way that all the robots can be repaired. So these are the conditions we have. Let's suppose the condition saying that all the robots move at the same speed. If the robot move in the same direction, they will never collide. Okay, if two robots move in opposite direction, they meet at some point and they do not collide, they cross each other. Okay, if robot passes by a factory, they reached its limit and it crosses its own if it does not exist. If the robot moves from position x to y, the distance we have to calculate y minus x. Okay, so these are the things we have given. Pause this, try to go through this, and we'll talk more further. So think about that. This is your robot. So the robot is at here 0, 4 and 6, we can say. This is the position of robot. Now think that we have a factory which is at 2 and which is at 6. Means at 6 we have the robot as well as the factory, other than they are different positions, right? So what we need to do, as you can see in the here, right, we have to find the distance. How will you need to find it? You can go through these steps and you can understand how we have calculated. Let's suppose the very first, the distance we have to calculate from here to here. So you know that two distances there from here to here. For this robot it's 2, so 2 plus 2 is 4, and for this, because it goes to this factory, so 6 minus 6 is nothing but a 0. Okay, so total is coming 4 as a answer. We'll try to understand more in detail these examples, and this is the constraint we have given. And why this constraint we are looking at, because you will understand that the position and the robot position and its limits is very far from our understanding here, because it gives you the combination of DP problem, right? Either you can memorize, you can use the DP table, or any other else you can also use. Okay, so we'll try to understand why we are going to use the DP. The thing is, we have given two things, right? The thing is, we have given two things. The very first thing is we have given robot. So this robot we have given at some position, and those position is on the number line, and those position are unique also, right? Like we have seen at 0, at 4, and at 6 the robot was there, right? Then we have factories. So at some position with the capacity, how many robot it can fix. The very thing is not given in this problem statement was what this capacity was do. Only it is saying the repair, but what is the capacity means how many robots can it fix, right? Now it is saying that the goal is, what is the goal we have? We have to assign every robot to a factory so that it can get repaired, right? So each factory does not exceed its capacity. If the capacity of the factory is 2, he can maximum repair. Like this factory, he has a capacity is 2, so he can repair this robot and this robot. Okay, if this robot will move to this side, right, to get repaired, it will not work. Why? Because it will not work because its capacity is done. Okay, then we have total distance traveled by all robot is minimized. So we have to also think that this robot will not come to here to repair, because if already is at some factory, he don't need to travel also, right? So you have to think about that thing also. Now think that robot we have given is at 0, 0, 4 and 6 we have given, and the factories we have 2, 2 and 6, 2 means factory is here and here. Okay, so each factory at position 2 can fix 2 robot, and factory at position 6 can fix 2 robot, means 2 robot he can fix and 2 robot he can fix, right? Both factories can fix it. Now sort everything. Why we need to sort everything? So if you will sort it, you know that you will get 0, 4, let's suppose we have to sort it, means 0, 4, 6 we have, and factory we have is 2, 2 and 6, 2. So sorting is critical, but this makes greedy and DP possible. That is why we have to do the sorting here. Okay, so let's suppose that what are the possible assignment that robot can do for this example. Okay, so let's suppose we try to assign the robot factory from left to right, means we'll go from left to right here, right, and we'll assign the robot. So very first robot is at 0, so it goes to factory 2, then distance is 2. Robot at 4 is goes to factory 2 also, and so assign 2, means this capacity is done. Similarly for robot 6, we go to the 6th factory because he doesn't need to travel, and so the distance covered is 0. So total is nothing but 4 that we have seen. This is the optimal approach. Let's talk about the bad approach. So if 0 goes to factory 2, that is fine. 4 goes to 6, this time is travel to this also gives the same result, but it gives you the same result, but it's a bigger in the bigger cases this will matter. So you cannot, like this should go to this one, right? It should not go to this one, that I'm trying to say. Okay, because in bigger cases it will not work, right? It will not give you the optimal answer. Okay, now try to understand the intuition. After sorting, the optimal assignments are always contiguous. So it means that if a factory takes robot, it will take a continuous chunk, right? Means no jumping around is there. Why? Because the distance is absolute. We have a minus b and it will give you some value. So crossing assignment always increases the cost. Okay, so we should not cross that. Now talk about the approach. So DP at IJ, you can use minimum distance that you use from robot to the factory, this, right? So each steps it will skip the factory or assign the K robot to 0 to the capacity, you can say that, right? So that is the thing. You can use any of the DP approach that you want from here, but let's try to understand again and how we are going to solve this problem. So very first thing, that if you read this statement, it will clear your understanding. So I'm saying, imagine a straight road, right, and the robot are parked at a various position. Like this is a straight road, right, and the robots are parked here like this we have seen, and the factory can repair them. So some factories are also there, right? Here we can take like that, right? So but each factory has a limited number of repair bays. So every robot must walk to exactly one factory. Either he will go to this factory, let's suppose this is a robot, either he can go here or here, right? What is our goal? Our goal is to minimize the total walking distance across all the robot. Okay, So this thing you have to keep in mind what we need to do. Now coming back to the key insight, like after sorting both arrays by position, the optimal assignment is always non-crossing, right? We should not cross, so we have to use non-crossing. If robot I goes to factory A, it means robot J should be greater than I goes to factory B. Again I'm repeating, if robot I goes to factory A, let's suppose this is factory A and this is, let's suppose this is a robot I. So if I goes to factory A, right, and there is another robot that is called J, this is your I and this is your J. So if J is greater than this I, right, this J is greater than I, that is correct, right? So in that case it goes to factory B, it should not go to the factory A, right? So then A is less than B, we can say, means factory A is less than B, that is also correct. So let us use a 2D DP scanning from left to right, so we'll understand. So let's suppose that we have a straight line where we have these robots we have given. At this position we can say this position we can, and this position according to the example at 0, 4 and at 6 we have seen, right? So we know that the robot is at where 0, 4 and 6, and the factory we have is 2, 2 and 6, 2, and our answer we have seen that we have 4. What we need to do, we will take the recurrence relation, right, where we'll say dpij is nothing but the minimum distance we have to calculate, right? So if dpi and j minus 1 means we have to skip the slot j. If we will use I minus 1, j minus 1 plus the slots, right, robot at I minus 1 and slot j minus 1, okay? So in that case we'll find the distance, right? So we'll assign the robot I to the slot j. Slot j is nothing but a factory, right? So in that case, let's suppose if we'll skip the slot, we'll get the value from here, right? If we assign the robot to the slot, right, then we'll get the distance. This one means we have to calculate this one and we'll have to add it. We'll understand here, don't worry. So let's suppose the robot goes to factory F1. It means it covers how many? It covers 2 as a value. Then R1 goes to F1 factory 1, means robot 0 and robot R1 both goes to a position here, right, and this value is 2. It means both is calculated, but R2 doesn't goes anywhere, it is at the same place we have the position, and we got total is 4 because 2 plus 2 is 4 distance he has calculated, right? Now we will expand the factory into individual slots, right? Means we will not we will expand each factory and will provide the individual slot. How? Let's suppose. So initial state is dpi I and 0 is 0 for all j, because 0 robots means 0 cost. If there is no robot, no cost is required, right? So we'll say 0j is 0. Now we'll say dp at I and 0, it is infinity for all I, because impossible to assign the robot with a 0 slot. So these two things we have to initially define, right? This thing I am talking about, this thing means dp at 0j is 0 and dp at I0 is infinity. I hope you understand. So what we will need to do, where and we can provide all this value. Let's suppose the dp at 0 at this place we will provide 0, 0, 0, 0 and 0. So we'll got that the 0 robot means the cost is 0, right? Now we have for all other cases, let's suppose for these cases we am talking about. So I0 means we'll go for all these things, it is nothing but the infinity will put, right? And then the rest of the thing is we have to calculate for these positions, we have to calculate. So let's calculate one by one. So very first that we have seen the recurrence relation is between I and j minus 1, and another was when we'll skip this one, right? We have seen that when we skip the slot, then this value will get, otherwise if we'll assign the robot to the slot, we'll get this value. It means we have to keep it here, right? Like this, these two conditions are there. When we provide a slot j, then we'll use this one, otherwise this one. So this is a skip part and this is a assignment part. So dp at I11 will use the robot I is equal to 1 and will say position 0 vs slot j equal to 1, right? Means position 2 we are talking about, right? It means we have to provide, so dp 10 is nothing but infinity, and dp 00 and 0 minus 2 is 2. So infinity and 0 plus 2 is nothing but 2 will get. So we'll assign the assignment here, right? Because this is our dp at 10, so we'll assign the value. Similarly, we'll assign the value for this one. So we'll keep calculating this value. As you can see, I'll keep moving. So each position we will add. As you can see, we'll calculate this where the assignment is not possible, right? As here you can say where the assignment is not possible means we calculate this dp to 1, so robot I equal to 2 and position is equal to 4 with only slot j. So minimum we will find like this and we'll get the infinity value, right? In that case it will keep infinity also here, okay? Otherwise we'll keep finding the value. So we found that very first, the first valid answer we have found right here, because dp at 2 we need to find how we have infinity value, and then we have a what is the value at 2 we have is 2 we have, and what is the current value we have calculated is 2. So 2 plus 2 is nothing but 4. So we will assign this value as a 4, right? Means both robots are now assigned, means first goes to slot 1 and second goes to slot 2, and the very first answer we have found. Similarly, we'll calculate that no improvement is required, right? Because the cost is already assigned, right? And for the robot 3, right, we got the slot 3 itself, because at the same position we will not calculate anything else, we will not do anything, non-improvement is needed. So we'll keep doing that, we'll keep assigning the value, and so once we reach the last position we will find that okay, dp at 3 4 means talking about this one, this value we will assign how the 4, because we have dp 3 3 we have is 4, and dp 6 minus 6 is 0, right? And dp at 2 3 is 4, so we'll get 4 from here, and from here we'll get 4. So 4 is 4, minimum is 4. So we'll assign this value, means total is nothing but this value. So it means we have expanded each factory into individual slot and we have assigned the value, right? I hope you understand. So in short, we can say the sort both arrays, expand each factory into individual repair slots, and then solve a classic one-to-one matching dp. At each cell we choose either skip the slot or assign the current robot to it. In that case, time complexity will give O of n cross m, where n is the number of robot, m is the slot, is nothing but the factory, and the space n cross m, where we have 2d dp array we have, and then we'll sort the first element, right? First we'll sort the first, where we need the sorting n log n. Now let's talk about the code. The very first thing we have seen that we have given the robots we have given and factories we have given. What we need to do, we will sort the robot and factory by its position. So you will sort like this. This is your array.sort, and you will pass the comparator here, where we pass a comma b, and you will do a minus b, you can say. Then we'll expand this, right, into individual slots. How will expand? 2 to 6 6 we will do that like this, right? And we'll convert into the slots. So how will you do that? From the factory you will get the value and you will keep assigning the into the slots. Now we'll say number of robots we will find and the slot size will know. So this is your dp array that we have seen, and the infinity value will take that. Okay, now we know that base case we have to check, where we have to check that 0 slots means impossible. So we'll define infinity like that, means dp at I 0 is nothing but infinity, but all other value that we have seen that 0 and j will be 0. So that is fine. So we'll create a dp, right, and we'll say okay, dp will go from 1 and I and j will start from 1 and goes to m and n, and we know that we have to skip the slot. So I and j minus 1 is dp at ij, so we'll assign that value, and if it is less than infinity, right, it means we have to get the absolute value. So how will we get the absolute value? Robot dot get I minus 1 minus slot get j minus 1 you will do, you will get the distance d, right? So what you need to do, you have to dp at I minus 1 j minus 1 plus you have to do is a dp distance. So the dp ij, which is just we have to skip it, right? that one we need to write, or the previous one plus the current distance, and we will update our dpij. The minimum thing we have to update because we need the minimum distance. So if the distance coming is minimum with the current one, so if it is that case, means we will update it. Otherwise we'll keep moving ahead and we'll find the at the dp nnm is nothing but the dp distance that contains minimum total distance will calculate it, as we have seen the each step, right? It means it's a bottom right cell we have, and means the last cell that we have, at that cell will get the answer. Okay guys, so that's all I have in this video. In case if you have any doubt, please ping me in the comment box, and for any suggestion are welcome. Please write the any query if you have, and please give thumbs up, like the subscribe button, and give support ExpertFunda support point of view, so we'll create a better content for you. Thank you guys, thank you for watching this video, and see you next. Thank you so much. Bye bye.